Hey, welcome. Today, we're going to dive deep into something called API security. Now, that might sound a little complicated, but don't worry. We're going to break it all down by building something together, a digital fortress. I mean, really think about it for a second. Every time you log into your bank, order some food, or even just check the weather on your phone, there's all this magic happening behind the scenes to make sure it's actually you. So how does all of that work without accidentally letting the bad guys in? Well, the secret is that every secure app you use is protected by layers and layers of defenses. Defenses that act just like a medieval fortress. And today, we're handing you the exact blueprint to build one yourself. So here's our plan. First, we've got to know our enemy. Then, we'll build our fortress, layer by layer, starting with the outer walls, then the gates that control traffic, and finally, the internal guards. We'll even figure out how to defend a whole kingdom of fortresses and, crucially, which common design mistakes to avoid. You can't build a strong defense if you don't know what you're up against, right? So let's kick things off by getting to know the most common threats that any public API is facing right now. And look, the threats are coming from all sides, and they never stop. Attackers are constantly trying to sneak in without permission, or scrape all your valuable data, or just plain steal user passwords. They might even try to knock your whole fortress offline with a giant flood of fake traffic, what we call a DDoS attack. And sometimes it's not even an attack. It could just be a simple power outage at a major cloud provider. A really good fortress isn't just one big, thick wall. It's all about having multiple layers of defense. So we're going to build ours with 4 critical layers. Those strong outer walls, really strict control over who comes and goes, a foolproof system for checking IDs, and a grand strategy for defending multiple fortresses at once. All right, let's get our hands dirty. It's time to lay the foundation and raise the walls. This first layer is all about stopping the most common and obvious attacks before they can even get close to your castle. Our outer wall is a piece of tech called a web application firewall, or just WAF for short. The best way to think of it is like a huge invisible shield that stands in front of your fortress. It inspects every single thing trying to get close and automatically blocks all the known troublemakers and sketchy-looking characters. Now, this is where it gets really cool, because we can customize our defenses. Managed WAF rules, think of those as your standard issue high walls and moats. They protect against all the common invasion tactics that everybody knows about. But custom rules? Ooh, that's like your secret sauce. These are the hidden traps and clever defenses you designed specifically for your fortress, protecting you from attacks that are tailor-made to exploit your unique weakness. Okay. Our walls are up, they're high, they're strong, but a fortress is pretty useless if you can't let your friends in and out, right? So the next step is managing the flow of people through the main gates so we don't get totally overwhelmed. And that's where something called rate limiting becomes your best friend. It's basically your team of guards at the gate, making sure everyone comes through in an orderly fashion. It prevents a massive mob, or, a malicious army of bots, from rushing the gates all at once and causing the whole system to collapse. And wow, this chart really puts it into perspective, doesn't it? On a normal day, you might get a few thousand requests a minute. During a holiday shopping rush, okay, that might jump tenfold. But a DDoS attack? That is a completely different animal. We're talking 1,000 times more traffic than normal. Without those guards at the gate, that tsunami would just wash the entire fortress away. So our defenses have let somebody pass the outer walls and through the gates. But we still need to check their ID. Who are they, really? And what are they even allowed to do now that they're inside? This next part is all about identity. We've got 2 main ways to check IDs. First, there are API keys. You can think of these like a simple old-school metal key. Yeah, it works, but if you lose it or it gets stolen, whoever finds it has full access until you can change the locks. On the other hand, you have OAuth 2.0 tokens. Now, these are like a modern hotel keycard. They can be programmed with very specific permissions, like you can only access the gym, and they automatically expire after a while, which makes them way more secure. And this is an absolutely crucial point. Just having the keycard, that's called authentication, isn't the whole story. The next question is, what doors does that keycard actually open? Can this person just read data? Can they write new data? Or can they only hang out in the public courtyard? That second part, that's authorization. Let's be real. In today's world, it's pretty rare to have just one single fortress. Most big companies have their apps spread out across multiple locations or different cloud providers like AWS, Azure, and GCP. So how on earth do you defend an entire kingdom? Here is the absolute #1 golden rule for this: consistency. It does not matter if one fortress is built with AWS tools and another is built with Azure tools. The security rules, the way you check IDs, the emergency plans, they have to be exactly the same everywhere. An inconsistent defense is a weak defense, just waiting to be exploited. So how do we actually pull this off? Well, you have to use a single, consistent way to identify your users across all your clouds. Your security policies need to be shared, not reinvented for each new location. And you can use smart traffic routing to send people to the closest, healthiest fortress. But most importantly, whatever you do, avoid building totally separate security systems in each cloud. That's just a recipe for disaster. Okay, we've built a pretty impressive fortress. But even the strongest walls can crumble if they're built on a shaky foundation. So let's do a quick lightning round. 4 common design flaws that you have to avoid at all costs. First up, the wall is not enough. Seriously, if you think just putting up a WAF is going to solve all your security problems, you're in for a rude awakening. It's a great first step, but it is not a complete solution. Second, and it sounds obvious but you'd be shocked, stop leaving your keys under the doormat. Hard-coding API keys or passwords directly into your app's code is the first place an attacker is going to look. It's like putting up a giant welcome sign for them. Mistake number 3, having different rules for different gates. This goes right back to what we said about a unified kingdom. If your security is super tough in one cloud but kind of lazy in another, guess which one the attackers are going to target every single time. And finally, don't ignore the possibility of a tsunami. DDoS attacks are a fact of life online. You have to assume one is coming. Designing your system to handle that massive flood of traffic has to be part of the original blueprint, not something you try to patch on later when you're already underwater. And there you have it, the blueprint for a modern digital fortress. We've walked through how all these different layers of defense have to work together perfectly to protect the apps we rely on every day. Which leads me to one last question. Now that you know how much work goes into building a truly secure system, how safe do you think the average app on your phone really is? Definitely something to think about. Thanks for watching.